Hi, this is Ms. Sigala, and here is the homework video for homework 1.4 for scientific notation. Okay, you will need a calculator towards the end. All right, the first portion asks us to express the following quantities in scientific notation. Okay, remember that when we talk about scientific notation, we want our generic formula. We want it to look like we're going to have the exponents. Okay, in this case, we're going to have a, and then times 10, and then to the n power. Okay, remember that the coefficient must be a number between 1 and 10. If the exponent, if the n is negative, hold on. If the exponent is negative, okay, then that means that the coefficient was originally less than 1. If it's positive, then that coefficient was greater than 10. Okay, well, that original number, okay, the number in ordinary notation. So let's look at the first number. We have 700 meters. We have to make that 700 first a number between 1 through 10. So 700, well, if I add a decimal point after the 7, or just 7, times 10, and in this case, in order to do that, I moved my decimal point over 2 places, and because this number, because 700 is greater than 10, then that means that my exponent will be a positive 2, and meters. Another rule to remember is that we have to keep, the reason I didn't add 7.0 is because if I add 7.0, in this case, then I'm changing the number of significant figures. Okay, my decimal point is present, here I would have 2 significant figures, but my ordinary notation number over here only has 1 significant figure, so my scientific notation must also have 1 significant figure. Okay, next one, we have 0.0054 kilograms. Again, what I can do is I can move the decimal point 1, 2, 3 places to make this number 5.4, and times 10. And in this case, I move my my decimal place over 3 times. And because 0.0054 is less than 1, my exponent is negative. Okay, and don't forget your units. Here we have 360,000. Again, I'm going to start at the very end. 1, 2, 3, 4, 5. So I moved it over 5 places. My number is now 3.6 times 10 to the 5th place, to the power of 5, and my unit is seconds. If you have to double check yourself, again, in this number for scientific notation, there's no, the decimal point is absent, so we would go from right to left. First non-zero number is a 6, so here we have 2 significant figures. My answer also has 2 significant figures. Next one, we have 0.00687. 1, 2, 3, 4. So my number is going to be 6.87. Times 10 to the 4th, and it's going to be negative because, again, this number right here is less than 1. My unit, kilograms. All right, next one we have 38,000 meters. 1, 2, 3, 4, because I want this number to be 3.8 times 10 to the 4th, and my unit is meters. Oops. All right, here's a really small number, and here we have to move our decimal point 1, 2, 3, 4, 5, 6, 7, 8 places, and that way this number becomes 7.6, which is between 1 and 10. And I write my the number of times I wrote or did I move my decimal point just to kind of remember? So when I come over here, times 10 to the 8th, and because this is a really small number, actually it's less than 1, my exponent will be negative. And my unit is kilograms. You can write that 8 just to be on the safe side. Negative 8. All right, here we have a really large number. And again, 1, 2, 3, 4, 5, 6, 7, 8. So I moved it 8 places, but this time I moved it over to the left. This number is definitely greater than 10. So in this case, my exponent will be positive. So my number is 6.85 times 10 to the 8th, and then my unit is going to be meters. Last problem, we have 4,500,000. So here I go 1, 2, 3, 4, 5, 6 places. My number becomes 4.5. Oops, sorry. 4.5. So it's 4.5 times 10, and it's going to be to the 6th to the power of 6, and my unit is meters. All right, next section for the homework. Now we're asking for you to express the following quantities, but in ordinary notation. We've been given the scientific notation. All right, and this one's actually a little bit easier. Let me write down the generic formula again. So a for the coefficient times 10 to the n power, or to the power of n. Now here, if n is positive, we're going to be moving our decimal point to the right. If n is negative, then our decimal point will move to the left. Okay, and if my exponent is positive 5, then I'll be moving my decimal point over to the right 5 times. So let's look at our first problem. Here we have 8.348 times 10 to the 6th power. Okay, so then in this case, if you feel more comfortable rewriting it, that's fine. So I have 8.348. So I'm going to move it over 6 times to the right side because this exponent is positive. So I'm going to go 1, 2, 3, 4, 5, 6. So I would add 3 more zeros. So my number in ordinary notation would be 8,348,000 kilometers. Okay, next one. And remember, we have to keep the same number of significant figures. Okay, here in my scientific notation I have 4 sig figs. Here in my ordinary notation it's still 4 sig figs. Okay, so we do not need a decimal point at the very end. Next one, it's positive, so I'm going to be moving my decimal point over to the right 3 times. 1, 2, 3. So my number turns into 3,402 grams. All right, here's my first negative number. So in this case, it's going to be moving to the left, the decimal point is. So if I were to write 7, I'm going to scoot over to the right a little bit, 0.6352, this decimal point will move to the left 1, 2, 3. So I'm adding 2 zeros in front of the 7. So this is a very small number, so it's going to become 0.0076352 kilograms. Next number, another small number. Why? Because the exponent's negative 5. So I feel more comfortable writing it down. It's going to be moving to the left. 1, 2, 3, 4, 5. Here's my decimal point. And add 1, 2, 3, 4 zeros. Okay. Remember, the exponent does not mean that you're going to add that many zeros. It means that's how many times you're going to be moving the decimal point. So be careful. So we have 1, 2, 3, 4, 302, seconds. All right, next one, an even smaller number, -8. So I'm going to give myself some more room. So I have 3.1587. And this time my decimal point is going to be moving 8 places to the left. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Teeny tiny number. Okay. So here my answer is 0. We have 1, 2, 3, 4, 5, 6, 7 zeros. 0 point. And then 3,1,587 grams. All right, my next number, my exponent's positive, so now my decimal point will be moving to the right 5 times. So I can actually maybe do it here. So I'm going to go 1, 2, 3, 4, and I'm going to add another 0. So my number becomes 102, 102,000 kilograms. Again, here I have a positive exponent, so my decimal point moves over 4 times. So 4.38, got 1, 2, 3, 4, add 2 more zeros at the end. So my number is 43,800 millimeters. Here I have a small number because my exponent is negative, so it's -4. So again, my decimal place will be moving to the left 4 times. So here's 1, 2, 3, 4. Place those little spaces with zeros, and I like to add a 0 in front of the decimal point. So my number becomes 0.000572 centimeters. Okay, very small quantities. All right, the last 2 problems are actually what we are going to get used to seeing in our homework problems in the near future. So in this case, how many atoms are there in 0.525 moles? And here we're given the conversion factor. So based on this, we're saying that 1 mole, which is a unit, contains this many atoms. Okay. Now we're trying to find out, here's a given. We are given 5.25 moles. All right, so let's start off with 5.25 moles. Okay, and according to this given, we are told that 1 mole contains 6.02 times 10 to the 23rd atoms. So in this case, I have to multiply. So I'm going to do some dimensional analysis. I want to get rid of moles. And according to this conversion, or to this equality, 1 mole is equal to 6.02 times 10 to the 23rd. I'm sorry, I can't really see that very well. Atoms. All right, so my moles cancel out. So now I have to multiply. Now I have to multiply 5.25, and make sure you use your calculator, times 6.02. Remember, if you're using the EE, you do not have to multiply times 10, okay, because that's automatically replacing that. And let's see. Our answer is 3.1605 E, or times 10, to the 24th power. Now, let's not forget significant figures, okay? So in this case, we see that our given has 3 significant figures. Our equality also has 3 significant figures, which means that our answer must have 3 significant figures. Here they are. Here's a doubtful digit, number 6. The 0 does not affect the 6 at all, so my answer really should be 3.16 E, or times 10 to the 24th atoms. right, next problem. Here they're telling us that, okay, same conversion. 1 mole of sodium contains 6.02 times 10 to the 23rd atoms. Now we want to know how many moles we would need to have 25.0 times 10 to the 23rd atoms. Okay, so here's our given. 25.0 times 10 to the 23rd atoms. Okay, and here's our conversion. Moles. But we want to end up with moles now. And so we want to make sure that we get rid of atoms. So atoms will go in our denominator. Let me get this a little bit smaller. So atoms. And according to the equality given, I'm told that 6.02 times 10 to the 23rd is equal, that many atoms is equal to 1 mole. My atoms cancel out. If you feel more comfortable multiplying the whole thing first, all the numerators, because remember, this number is always over 1, then I'm going to end up with 25.0 times 10 to the 23rd moles, because that's my surviving unit, over, well, 1 times 6.02 times 10 to the 23rd is 6.02 times 10 to the 23rd. And there's no unit because we canceled it out. So now we're going to divide our numerator by our denominator. So be careful when you're typing this into the calculator. I'm going to divide it by 6.02. And we're going to end up with 4.15 to 8 moles. Okay, now again, I want to look at my significant figures. Okay, and here I have 3 significant figures, 3 significant figures. So I want my answer to have 3 significant figures. Here's my 3 significant figures. Here's my doubtful digit. My 2 does not affect my 5, so it'll remain as 4.15 moles. All right, the next problem says a mole of hydrogen atoms contains 6.02 times 10 to the 20. I'm sorry. Yes, a mole of hydrogen, 1 mole, contains 6.02 times 10 to the 23rd atoms. A section of outer space contains 25 atoms. How many moles of hydrogen is this? So it's very similar to the previous question. Our given is 25 atoms. We want to end up with moles. And we want to get rid of atoms. So atoms is going to go in our denominator. And mole will go in the numerator. So according to the equality given, I'm told that 1 mole equals this many atoms. So 1 mole equals 6.02 times 10 to the 23rd. My atoms cancel out. So now I'm going to do the math. And remember, you're going to end up with your numerator, which is 25. In this case, your surviving unit is moles, over 6.02 times 10 to the 23rd. When I put this into my calculator, my answer is 4.15 to 8 moles. Again, I look at my significant figures. How many sig figs do I have here and here? Because I'm multiplying, I go with the least amount of sig figs. So I have two significant figures. So my answer should have two significant figures. Okay. Here my 2. Here's my questionable digit. Does my 5 affect this? Yes, it does. So my answer becomes 4.2 moles of hydrogen. In this case, I'm just going to write the symbol.